So in this problem, we need to show that square root of 1 minus cosine 2 theta divided by 1 plus cosine 2 theta equals tangent of theta. Let us begin. So here we will start a problem from the left hand side. So here we will start with the given expression. We have the square root of 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. So here we know that cosine 2 theta, which is the trigonometric ratio of a multiple angle, can be also expressed as cosine squared theta minus sine squared theta. There are two more forms. One form is 2 times cosine squared theta minus 1, and the other form is 1 minus 2 times sine squared theta. Now the goal will be to convert the numerator 1 minus cosine 2 theta. We have two terms here. Our goal will be to convert it into a single term, because if we use the formula cosine 2 theta and 1 minus 2 sine squared theta, that means we have cosine 2 theta equals to 1 minus 2 sine squared theta. So if we rewrite it, we're going to get 2 times sine squared theta equals to 1 minus cosine 2 theta, which means we can replace the two terms in the numerator with 2 sine squared theta. Similarly, if we use cosine 2 theta equals to 2 times cosine squared theta minus 1 and rewrite this, then we're going to get 2 times cosine squared theta equals to 1 plus cosine 2 theta. Okay, so let's replace this value. So we're going to get the square root of 2 times sine squared theta divided by 2 times cosine squared theta. We can factor out the 2. This is going to give us the square root of, so sine squared theta over cosine squared theta, that's tangent squared theta. That is going to give us tangent theta. So this will be equals to the expression on the right hand side, hence proved.